Welcome, U2004961 Muhammad Alif Aiman here. Today, we are presenting on the summarization of all experiments conducted from home for the course SIF1006 Practical Physics. The experiments shown in the video are just concepts of the actual experiments that were done. Without further ado, let's move to experiment 1, where we'll find the speed of light surprisingly with a chocolate bar. First, place the chocolate on a tray, then heat it up in the microwave for 20 seconds. Pull it out, then press it. By pressing the chocolate, we can see where it's actually melted. The melted parts represents half the wavelength of the microwave. Measure them, then calculate the speed of light. The measured results had a 3.57% error and agrees to the theoretical speed of light. For the next experiments, we will get a little help from Firefox. Firefox is an app for Android and iOS that uses the phone's built-in sensors to collect data and do interesting experiments. For this experiment, we are looking to find the radius of the circle during centripetal acceleration. Centripetal acceleration is the property of motion of a body traversing a circular path. First, a cardboard piece is taped to the side of a stripped-down rotating chair frame, which is 20 centimeters from its center. Then, the phone is placed in the slot. We then spin it using our fingers for 20 seconds and repeat it for about 3 times. Firefox measures the centripetal acceleration every 0.5 seconds for the duration of the experiment. The results were graphed as such, and the gradient corresponds to the radius of the circle. The results agree to some extent, and the experiment yielded 1% error. Moving on to experiment 3, we only need to add a source of sound to the apparatus to study the Doppler effect. The source will play a 1000 Hz sound such as this. To further elaborate, the Doppler effect is the change in frequency of a wave in relation to an observer who is moving relative to the wave source, who was named after Australian physicist Christian Doppler. Same as before, we only need to spin the frame using our fingers for 20 seconds, and Firefox will do the rest. The results were graphed and showed a linear relation between the frequency observed and the velocity of the observer. The negative velocity represents the source moving away from the observer and vice versa. It also has an accuracy of 99.99% even when doing it at home. Finally, for experiment 4, we have to remove both the speaker and frame, and replace it with this box here to study the phenomena of sonar. Next, add a blanket into the box. It will act as a sound absorber to make sure our sound waves don't bounce around inside the box and affect the experimental outcome. Then, place the phone under the blanket. Make sure that it is not blocked by it. The phone will play a chirp like this, which will be reflected for Firefox to collect the necessary data. We also need a solid object to reflect our waves. The object is then placed at 50 centimeters, 100 centimeters, 150 centimeters, and finally 200 centimeters away from the sound absorber. By graphing the results, we get that the distance and the time taken for the wave to be reflected also has a linear relationship, such as the experiments before it. It also had a 0.01% error for the distance and a 0.003% error when calculating for the speed of sound. To conclude, here are the results of all the experiments again. This shows that experiments are doable from home, but it's still not ideal due to the lack of instruments to reduce errors and obtain perfect dataset. Thank you for watching.